Alright. So here is our first problem. I want to solve this. From here, what do you think you would do? Okay, add your 2 over. Our first step, if possible on these, will be to isolate the radical. So what I would prefer is to have my radical on one side of the equal sign and anything else on the other. So I just moved that 2 over. Now, we really would like to get rid of our radical. So what is the opposite of a cube root? Cubing. Yeah, taking it to the 3rd power. So I'm going to cube each side of this. Okay, so those actually cancel each other. So you have 2x minus 4 equals 2 to the 3rd power is 8. Okay, then this is an equation you can easily solve. Add your 4 over, divided by 2. So 2x equals 12, and x equals 6. One thing I really want you to get in the habit of doing on these problems is to check your answer. The issue is when you start adding squares and things into your problem, you can sometimes get extra answers. So we might get an answer, but then when we plug it back into the original, it doesn't work. So it's very important on every single one of these problems, you have to check your answers and make sure they do actually work. If we plug in our 6, that's 12, minus 4 is 8, cube root of 8 is 2, and 2 minus 2 does equal 0. So this one does check out. If it didn't work when I plugged it back in, what would I say? No solution. If you get 2 or 3 answers, you have to check every single one of them. And it's possible that one might work and another won't. So always check your answers on these radical problems. Okay. I'm going to give you guys one. Solve that one for me. Alright, so this one, the radical is already by itself. So we can jump right in with cubing each side. So you get 2t minus 1. 1 to the 3rd is just 1. Add 1 over, divide, and you get t equals 1. Check it. Plug it back in the original. You get the cube root of 1, which is 1. And so it works.
I thought it had to equal 0.
It has to equal whatever the equation is. So this was my original. You're just seeing if I put this in, does it give me a true statement? So if I put that in, and that is true, so it works. All right, next one. I have the radical by itself. So we first start by squaring. You have to be really careful. When we square, we're not going through and adding a square on every term. When you square, you have to do each side of the equal sign. Okay, so on the left side, the square root and the square cancel and you have x minus 1. But what happens on the right side when you square that? If you square that entire side, how do you do x minus 7 squared? Foil it. That just means you have 2 of them, so we have to foil. So that's x squared minus 14 x plus 49. Okay, this is a quadratic. What do we do with our quadratics? Right, we do box method. But before I can jump into box method, I have to set them equal to 0. So I'm going to subtract over my x, it's a negative 15, and add my 1, so plus 50. So now because it's a 1x squared, we can do the shortcut.
Wait,
Mhm.
when you say set it equal to 0, you want the left side onto the right side or vice versa?
Yeah, I
Just
basically,
to take out each equation and set it equal to 0?
no, I'm just getting everything on one side. And I moved it to the right so my squared term would be positive.
That negative 15, negative 15.
Oh, never mind. I was looking
Okay, are you sure?
Yeah, I see what it is.
So, what multiplies to 15 adds negative 15? Okay, so if you set each of those to 0, you get x to be 10 and 5. Am I done?
No pressure.
Check. Okay. So when I check these, if I put in a 10, you're putting it into the original. So I get the square root of 9 equals 3. Is that true?
Yes.
Yes, so 10 works. If I put in a 5, I get the square root of 4 equals negative 2. Does that work? No. So 5 does not work, and 10 is my only answer. All right. Questions there? Yes, ma'am.
How come the bottom one didn't?
Because the square root of 4 is positive 2, and the other side is negative. And that's going to be what comes up a lot of times with squaring. One side will be positive and the other will be negative, and that's why it won't work. Let's do this one. Extra radicals. They're so much fun, we need more of them.
Can we do like a, to the fourth part, will it cancel out radicals, or is that like not legal, I guess?
It would be if it weren't for this 2 right here. So that would be perfect.
If it just had like a radical?
If it had just like a double radical there, yes, that would work great. So instead, let's start on the outside and work our way in. Okay. On the outside, I have this big radical. So how would I cancel that? Square. And you add your square to each side. Okay. So on the left, you're starting on the outside. So the square cancels the outside radical. So we still have a 2 square root of 7x plus 2. On the right, my square does cancel that radical. So it's a 3x plus 2. That looks significantly better. What can we do now? Square it again. We still have a radical, so we have to square a second time.
So,
Did you have to get rid of the 2 or no?
yeah.
So we have 2 options. We can divide this 2 over and square. It'll give us a fraction, but very doable. The second option, if we leave it, since they're multiplied together, you can leave it, but you'll just have to square both pieces. So would you rather divide it and have a fraction, or do you just want to keep it and square it? Okay.
And the reason we can do the 4 is because then you'd have to multiply the 2 by 4. And
Yes. So when I square this, I have to square the 2. So 2 squared would give me 4. And then I square that radical and it drops. So you get 4 times 7x plus 2. So the only thing you have to watch is if you don't move that 2 over, make sure you're squaring it. Now if it were added or subtracted with my radical, I would have to move it over first. On the right, how am I going to square this? FOIL. 6x and plus 6x would be a plus 12x plus 4. Next step. So 12x minus 28x, negative 16. 4 minus 8 is negative 4. Can I do the shortcut? No. Full box method. So I need two numbers that multiply to negative 36 and add to negative 16. Right, set each of those to 0. We get a negative 2 over 9, and positive 2. Am I done?
No.
I have to check. Okay. I don't mind if you use your calculator to check these. You don't necessarily have to show me a lot of work. So we're plugging the negative 2/9 into both sides. I don't have enough room. Alright, so just use your calculator. Plug negative 2/9 in to both sides. And let's see if we get the same thing. So you're going to get a nasty decimal, and that's fine. The question is, do you get the same decimal for both of them? I did. I did. You did not? You need me to look at it? So negative 2/9 works. The second thing we have to check is 2. So plug in a positive 2 for both of them. And it does give me an equivalent decimal again. So this time, both of them work.
When we work it out, do you want us to put the decimal or whatever we got down to?
You don't have to. I'm not going to, like, on a test or quiz, I'm not giving you points for showing that you checked it, because I don't mind if you put it in the calculator. But if the answer doesn't work and you fail to knock it off, then you'll lose points. So that's up to you, what you want to write down. Just show me that you checked it. You don't necessarily have to write anything.
I was just wondering if you were going to take off for, like, giving you the answer of what you would get if you checked it.
Oh, no.
Or,
No.
and then we'll answer too.
Yeah. Okay, I am going to kind of jump. I want you guys to do. I want you guys to try this one, I think. I saw you guys doing two different things. Some of you added over the 3. Then here's where a few of you were confused, you were wanting to like divide by x plus 2, but it's not all multiplied together. Just take one step at a time. The x is added, so to move the x you would subtract it. So you have 2 radical x equals 3 minus x. And then at this point you could square. You can't subtract that 2 over because it's multiplied with our x. Some of you also just started out by subtracting the 2 radical x over, and either way is fine. At this point we need to square each side. So this would be 2 squared is 4, radical x squared is x. Over here you FOIL, so you get 9 minus 6x plus x squared. If you did this way and you square, you get the same thing, because if you take a negative 2 and square it, negative 2 times negative 2 is positive 4. So we should be at the same point now. It's a quadratic, so we set it equal to 0. So subtract your 4x over. Then we can do the shortcut. Multiply to 9, add to negative 10 would be negative 9 and negative 1. Set them equal to 0 and you get 1 and 9.
Now when you plug it in to check it, do you do the original?
Yes, always plug into the very original. So if I put in a 1, I get 1 plus 2 minus 3, which does equal 0. If I put in a 9, I get 9 plus 2 radical 9s, so that would be 6. Does 15 minus 3 equal 0? No, so the 9 does not work, so 1 is my only answer. Let's try some more. This one we have 2 radicals. We need to get rid of one at a time. Okay? So add one of them over. Okay, so if I'm focused on the left side right now, to get rid of this, you would just square. And we square each side. On the left, the square and the radical drop. On the right, can I just drop my radical? What does this mean I have to do? Yeah, because of that addition, we have to FOIL. Okay, so here we go. 2 times 2 is 4. Plus, multiply those, you just get 2 radical x plus 2. Plus another 2 radical x plus 2. If you FOIL or multiply those, you get radical x plus 2 squared, which what happens then? Cancels, and you just get an x plus 2. Okay, so right now, if I add like terms, this is a.
If we were going to end up with 2 radicals on the right side again, why wouldn't we just...
I don't know what I'm asking quite yet. I don't know.
It's
Yeah.
because these things are 2 separate terms added or subtracted together. That's why we're going to have to deal with the radicals longer. We can't just take it to a 4th power or something and get rid of them.
Okay.
These are like terms, so we can add them. So it's 4 radical x plus 2. And then if you add the 4 and 2, you get x plus 6. So now I'm down to a problem with 1 radical. Can I get this radical by itself? Yes, if I subtract over my x, that gives me an x. Subtract my 6, that's minus 3. And so now, this is like the problems that we were doing in the last couple examples. So now we square. How do you do x minus 3 squared? FOIL, so we get x squared minus 6x plus 9 equals 4 squared is 16 times radical x plus 2 squared is x plus 2. Distribute your 16 and then it's quadratic, so if we set it equal to 0, subtract over our 16, subtract over the 32, multiply negative 23, add to negative 2. So we get x to be a negative 1 and positive 23. Okay, and then check it. Okay. I put in a negative 1 in the original. That'd be negative 2 plus 3, so 1 minus the square root of 1 equals 2. Does that work? No, we have 1 minus 1 equals 2, so that doesn't work. If I put in a 23, so 23 times 2 is 46, so 49 minus radical 25 equals 2, so 7 minus 5 equals 2, and that one does work. So my only answer is 23. So those are a little bit longer because you have two radicals added or subtracted. We have an extra step in there. Want to try another one like that? So first step, and then square. So on the left, the square root and the square cancel. On the right, you have to FOIL. So 2 times 2 is 4. 2 radical x minus 1 and 2 radical x minus 1 will give us a 4 radical x minus 1. And what happens when you take radical x minus 1 times radical x minus 1? Cancels the radical, and so we just get the x minus 1. So you have 3x plus 1 equals 4 radical x minus 1 plus x plus 3. Okay, next step. Subtract our x. Subtract the 3. Then what? Square.
Where did you get the x plus 3?
I added my 4 and my negative 1.
Okay.
Okay, so if we square again, side. You're foiling, so 2x plus 2x would be 4x squared. Minus 4x and minus 4x would be minus 8x plus 4. Over here, 4 squared would be 16. Radical x minus 1 squared is just x minus 1. So if we set this equal to 0, subtract over our 16x, that's a negative 24. Add my 16, that's 20, equals 0. What do you notice about that? So then we can do the shortcut. Multiply to positive 5, add to negative 6. Negative 5 and negative 1. Does 4 ever equal 0? No. What makes x minus 5 0? And x minus 1? Okay. And then plug them in to check. Okay, so if I put in a 5, I get 4 minus 2 equals 2, that works. If I put in a 1, I get 4, so 2 minus 0 equals 2, and that also works. So this time, both answers check. All right, questions on that? I think I'm going to do maybe 1 or 2 more, and then I'm going to stop. I'm going to jump to the back. So I'm going to do this problem. Can we what? We can't distribute it. Okay, a 1/4 power is the same as a 4th root. Whoops. How do you get rid of a 4th root? Fourth it. 4th power. Okay, so those drop. So then, if I set this equal to 0, I want my 4th power to be positive, so I'm going to subtract over my 5x squared, add over my 6. This is like one of your test questions now. Familiar. We can do box method with this. X to the 4th would break into x squared. What multiplies to 6 and adds to negative 5? That multiplies to negative 7. So we get x squared equals 2, x squared equals 3, square root plus and minus, so x is plus and minus radical 2, plus and minus radical. Okay, so how many answers do I actually have here? 4. Okay, if I check these, if I put in a positive radical 2, radical 2 squared is just 2. So that gives me 4. So does the 4th root of 4 equal the square root of 2? Well, how could you figure it out if you don't know?
Let's ask the calculator.
Okay. Yes, it does. So positive radical 2 works. If you put in negative radical 2, negative radical 2 squared is still 2. Then this would be a negative. Does the 4th root of 4 equal a negative radical 2? No. The negative isn't going to work. It's a positive. Okay, so far, radical 2 works. If I put in a 3, radical 3 squared is 3. So that's 15 minus 6 is 9. So does the 4th root of 9 equal radical 3? Yes. Will it work if I put in a negative radical 3? No. So my answers are the positives, radical 2 and radical 3. It all depends on the original setup. Like if you have a radical on one side, like even radical, and if it's just plain x on the other, then it's radical. But if it was like a number on the other side, it's not. Okay, I am going to stop here. We are not completely done with this section. However, we have a really good start on it. The assignment is on MathXL. There are 13 questions on this. We have not done every type, but they're kind of jumbled up, so I can't just say you know how to do 1 through 5 or anything like that. You could do, trying to look real quick. You should be able to do 1 through 6. Um, 12 and 13 so far. So this is not actually set to be due until Tuesday. Monday I'm going to do a few more examples and then hopefully get you a little more class time to work. However, you can get started on this. Like I said, right now you already know how to do 1 through 6, 12, and 13. So it's just a few in the middle that we haven't done a similar problem yet.